So we are going to discuss solutions of this differential equation, mostly qualitatively, subject to these four initial conditions. Okay, so one initial condition is that we start at negative 0.5 and then we have the others. So the way we are going to look at it, first of all, say we exhausted all our analytical techniques and couldn't work with it, that let's look at the sign of this quantity, because that will tell us that where dy dx is positive, negative, or zero. So if this is positive, you know y increases there. If this quantity is negative, okay, if dy dt I meant, if dy dt is negative, y decreases, and if dy dt is 0, then what happens is y is going to be a horizontal line as a solution. So if we look at that, what we have is, so here let's look at a table. So here first we have y, and on this part we shall put this in, the value of dy dt, and let's just go in our usual style for trigonometry, that is the values from our standard triangle. Okay, so pi over 6, pi over 4, then pi over 3, and then let's go for, say, pi over 2. So what we notice here is that when y is 0, okay, what we get is we got 0 here and we got 0 here, and this value will of course be 0, right? So here we are writing what this is, positive or negative. So there it is 0, and now here say we put pi over 6 here. All right, so pi over 6, okay, minus sine of pi over 6. So what that becomes is, we have, what do we have here? We got 1/2, and then sine of pi over 6 is also 1/2. So there, this value is also 0. So now let's look at pi over 4. So there we got pi over 4 here and pi over 4 here. So what we get here is, we get 3 over 4 minus how much? Square root of 2 over 2, or 1 over square root of 2. And this quantity, you can see it is a positive quantity because that's all we are interested in right now. And for pi over 3, by now you must have realized that if we write pi over 3 here, this is pi over 3, so that's 1 here, and sine of pi over 3 is how much? A square root of 3 over 2. I didn't have to write all that. And this is also what? This is also a positive quantity. And so you can see, the moment we just exceed the value pi over 3, this quantity here is going to become more than 1, and sine of y is always less than or equal to 1. So when y is more than pi over 3, this quantity is going to stay positive. So anyways, let's just write this down just for the sake of writing it. So here we got 2, here we got 2. So pi is cancelled. So what do you get? You get 3 over 2 minus 1, of course, that is greater than 0. And even if I change the signs of all these quantities, the things are just going to reverse. Okay, so what we notice is this, that is, this value is 0 at 0 and pi over 6, and also at negative pi over 6. Why don't we go ahead and look at a graph of just this function as it is, all right, and see how it looks like if we graphed it, and treating, you know, this y as input variable. So let's just examine that for a second. So what I have done here is that I have graphed 3 over pi y minus sine y for you. And so you can see that this is how this graph is going. So how about we did this, that is zoomed in, and it depends like which software you are using for graphing. You can see that here the 3 points where we got these values of dy dt equals 0 are negative pi over 6, 0 and pi over 6. Now remember this, our objective is what? So we would like to obtain the solutions of this, and what we shall have is this, that we would like to write y as a function of t, and what we just saw is this, that dy dt is 0 for y equals 0. So one of the solutions is y equals 0, and then dy dt is 0 at y equals pi over 6 and y equals negative pi over 6. And what we saw was this, that in here, if you look at this portion in here, the function is, the derivative is positive here, so it will be increasing, and then the derivative is negative here, so it will be decreasing. Likewise, the derivative is negative in this portion, so that will be decreasing, and it is positive in this portion, so that will be increasing. So what we are going to have now is that first of all, you can see that our y, therefore, y is increasing for y in which interval? These are the two intervals where it's increasing. So one of them is negative pi over 6, 0, and the other interval is, so one is pi over 6, and we can write infinity here. And on which intervals does y decrease? It decreases on, if you look at it, first of all, it decreases on this negative infinity to negative pi over 6, forgive my handwriting, and then union, then it decreases here, so that's 0 to pi over 6. And then what happens is, you can see right here, the arrows are coming towards each other, so this will be asymptotically stable. Now here, these are diverging, so you have an unstable situation. Okay, and if you want to see the details of it, how the solutions look like, since we cannot solve it analytically, you can go ahead and check MATLAB. All right, so here we have a MATLAB output. All right, and I'm posting the command into this video. You can see in the script section. So here you can see this is y equals pi over 2. This green line is y equals 0. And this line is y equals negative pi over 2. Okay. And then you can see that here we have the graph for the initial condition corresponding to 0.5. All right, and this one is the one that corresponds to the value at 0 equals negative 0.5, and here let me just indicate it. And in here I just supplemented this, that this one corresponds to y0 equals negative 0.7. Here you can see the graph passing through 1, and I just supplemented another one here for y at 0 equals 0.7. Okay, so yeah, let me know if you have any further questions.